Hi everyone, welcome back to the JavaScript course. We are at the topic number 49 and this is a crucial one actually. Today we are diving deep in scope, nested scope, lexical scope and scope chain. This topic ties together so many concepts we have learned previously the variables, functions, closures, execution context and hoisting. By the end of this video, you will understand how JavaScript decide which variables are accessible where and why that matters for writing a better code. So let's jump in. First question is, what is scope? So simply put, scope determine where variable and function are accessible in your code. It's like the visuality or reach of a variable. Okay. JavaScript has the three main types of scope. First is number one is global scope. Number two is functional scope. We also called it the local scope. And third is block scope. Okay. So one will be global scope. Second, function scope. Okay. So another we also call the local scope. And third point will be block scope. So let's see each one in action. Maybe it would be helpful. Suppose the global scope first. Check this code. Actually, this is a global scope. Here, global var is the global scope. So it's accessible everywhere inside function, block, anywhere in your code. This is accessible. Okay. Now the functional scope. It was a functional scope. And function var. This function var only exists inside this function. Outside of it, JavaScript can't see. You'd see reference 0, not defined. That function scope. Actually, a variable declared inside a function are local to that function. Okay, that's why the another name is local scope. So finally, the block scope. This is a block scope when you are using the bracket. Okay, it's with the const and let variable are block scope. Remember, this const or let, they only exist within the curly braces or bracket where they are declared. Okay, these include if statement, loops, or any code block, any text. This is different from var, which is function scope and can lead to confusion, right? That's why we prefer const and let. Always use those two variables. Okay, now the nested scope. So let's talk about this nested scope first. Okay, when you have a function inside the function or blocks inside blocks, you create nested scopes. Think of it like the boxes within a boxes. The key rule is here: inner scopes can access variable from outer scopes, but not the other way around. Okay, what it means? You see, the inner scope, this inner function, actually, this inner function can access outer, middle, right? Outer bar and middle bar and inner bar, but outer can't access this. Outer can't access the inner bar. You notice, because it's declared inside the inner. Remember, it's declared inside this inner, right? So scope flows inward, not outward. Think of it as a one-way mirror. Inner functions can see out, but outer function can't see in. Okay. So here is the another example. So this is with the blocks actually. Each level, you notice, each level of nested create a new scope, and inner scope has access the outer scope, right? Actually outer variables, but never the reverse. Carefully see data, then this the if statement, there is a temporary result is processing, but you are accessing the data from outer side template this side loop. But when you are console log the loop, it's showing a reference 0. because this is your block scope. Remember, this is a block scope. In this block scope, you are calling this loop bar, right? And also here you also get the reference zero. Great. I hope you understood what is the nested scope um, and what is the how scope is work. Now, where it gets really interesting. Actually, here's the interesting part. The lexical scope, also called the static scope. This lexical scope, also called static scope. Okay. Anyway, it means that the function's scope is determined by where it's written in the code, not where it's called from. Okay. This is absolutely fundamental to understanding JavaScript. So let me show you. Did you see? Even though we call this grid inside the another function where name is Bob, right? Name is Bob. It print the Alice. Did you notice? It print Alice. Why? Because the grid was written in the global scope. Do you notice? This is a global scope where the name is Alice already defined here. That's why when we are calling this grid, it's only printed out this name, not this name. But here is another twisting part. We just call this. I mean, we just stored the value in the constant, but we didn't call this value here. There is another point. But anyway, we didn't pass argument. But this is the scope. You see, when you are calling this another function, it's only call execute this grid, and you get this global scope from the global scope with the value. Okay, so lexical scope means JavaScript determines what variable a function can access based on where the function is defined. Remember, where the function is defined. Now, where it's executed, actually, sorry, not where it execute. It doesn't matter where you are actually executing this. So it actually checking where the function is defined. So the scope is lexed. I mean this lexed. Okay, or determined at right time. Determine the right time. Determine at the right time. Okay. So here is the another example. So even though inner, actually this inner is execute outside of outer, right? Execute outside of outer. It still has access to out verb, right? That's because the inner has a defined inside the outer scope. Is this inner function defined inside this outer scope, right? This is the foundation of closure. Remember, this is the foundation of closure, which we covered earlier, right? We already know what is the meaning of closure with the lots of example. I already show you. So do practice more, try to understand. Now the scope chain. This is interesting actually. Now let's put it all together with the scope chain. When JavaScript needs to find a variable, it actually follow a chain from the current scope outward. Okay, like initially first point is check the current local scope. Secondly, if not found, then check the outer scope. Thirdly, keep going outward until you reach the global scope. Okay, if it's still not found, then throw in reference zero. Okay, so look at this chain. This is your global scope, right? First level, second level, third level. In third level, you are calling 3, 2, 1, and this is 100% okay. You get your result without any issue. And you are calling this third here, second here, and first here. And did you see when you are calling this, you get second, first, global. Okay, that means JavaScript start at the innermost scope. And what is it? This third level, and work it way outerward through the scope chain. Then the second one, then the first level. Okay, this chain is created based on lexical scope where functions are defined, not where they are called, right? You see, initially second. So first is third level, then this third level, and then the second one, then first one. Okay, anyway, good. Now, variable shadowing. Let's see what happens when variables have the same name in different scope. What is happening? Message, message, message. Notice JavaScript found this message is the current scope. So it stops searching. You see, outer when we call the outer function, it's get initially inner function. This is the nearest one. Then outer, this one. This one the closest, right? From this one. This is the nearest. And this one is after it. So when you are console log this message, it actually calling this global message, global variable. But when you are calling the function, it's actually check the function nearest one. Actually, this scope chain stops as soon as it finds and match at any level, and this is called the variable shadowing. While it's not always bad, it can lead to confusion. So be careful when naming variables in nested scope. Be careful. So that's why most of the time or all the time we are using different variables name. Otherwise, it's conflict. It would be conflict. So okay. Now the scope chain in action. Actually, let's look at more practical example. This usage the scope chain beautifully, and you see increment, decrement, get count, all are okay. There is no problem. The increment and decrement and the get count function all close over the count, right? Count variables from their outer scope actually, right? They form a scope chain that keeps count private but accessible in these three methods. Yes, it's true, right? We can access this count in this inner scope because our count in the outer function. So you can't access count directly from outside, only through the method. So that's why you see when we are using the increment decrement, it's written good, but when we want to use this count, we use the counter. Remember this counter, call this create counter function, then we are getting this count. If we try to counter dot count, and it's given a undefined value, not an error. Remember, not an error. Count given a undefined value, initial value. Okay. So let's take the another real world example with the API configuration concept. Example. The get and post function have access to both base URL, right? This base URL, both function, and the API key also. This API key also, and this base URL and API key through the scope chain. Okay, even though those variables aren't passed as a parameter, right? They are remembered from the outer scope. Exactly, right? This is the base URL. We get the base URL. Also, we get the API key. They are remembered because this is the outer scope, right? So this is an example. You see, when you are console log it, you get the actual result. Here and API.get, then you get the output. And if you are using the post, then you get the post output. This is a very good example. Please do practice. Try to understand line by line. Then if you are facing any problem or you are confused, write your question in the comment below. I will give you an answer. So next is scope and performance. And one thing notes, the scope chain does have a small performance impact. The deeper you nest functions and the longer the scope chain, the more work JavaScript has to do the final variables. What it means? First, second, third, fourth level, right? You see, for most application, this is actually this is negligible, but in performance critical code, keep your scope chain reasonable. Otherwise, don't do this. Okay, without any reason, don't nested any code. There is a little bit performance issue have. So now the common pitfall. Actually, let me show you the classic mistake with the scope and loops. Why does this happen? Because var is functional scope. We know that, and not a block scope. All three functions share the same index or same I. which end up being the after the loop completes. So how to fix it? So use let. This is the solution function. Okay, use the let, and here use the verb. Okay, use let, then you get your answer properly. Okay, actually this let each iteration create a new block scope with its own eye, right? So each function closes over a different value, right? That's why it gives you the actual output what we want to see in the terminal or browser. 0, 1, 2. So okay, let me give you a mental model actually. Think of a scope as a building with a floors. Okay. So initially thought the global scope is the ground floor. Okay, and this scope, I mean this global scope can access everywhere. Then second is each function create a new floor, and you can look down from your floor to see lower floor, I mean the outer scope, but you can't look up to see higher floor, I mean the inner scope. When you need something, you check your floor first, then go down floor by floor until you find it. Okay, what it means, this is the line I'm just saying. Okay, global scope, this is your ground floor, then function create a new floor, each function actually create a new floor for you. Then for your floor, I mean the down floor, to see the lower floor, just think as outer scope. You can't look up to see the higher scope because this is the inner scope. When you need something, you check your floor first, then go down to floor by floor, okay, until you find it. So this is the code example. Okay, you see, this is your ground floor, this is your first, this is your second, and you get the access from the second floor. Actually, from the floor you can see the my floor, I mean your second floor. Okay, then the one floor down, the first one, and the ground one. Okay, you can see everything. And from the second floor, from the first floor, you cannot see the second floor, right? And you see the reference error here, and that's it. And this is your scope chaining visualization part. Okay, let's recap everything we covered today. Scope determines where the variable and function are accessible. Global scope is accessible everywhere. Functional scope limits variable to within a function. Block scope with the constant let limits variable to within a block scopes. Nested scope allow inner scope to access outer scopes, but not the vice versa. Okay. Then the lexical scope means the scope is determined by where code is written, not where it executes. The scope chain is how JavaScript searches for variables from inner to outer scope, and variable shadowing occur when inner scopes declare variable with the same name as the outer scope. Then you get actually facing the problem. So understanding scope is absolutely critical for writing clean, bug-free JavaScript. It affects how you structure your code, how you organize your functions, and how you manage your data. So in our next video, we will introduction the object-oriented programming and see how this scope concept apply to creating objects and organize larger application. So if you found this helpful, give it a thumbs up, subscribe if you haven't already. I will see you in the next one. Bye bye.